So before we begin the video, I just want to say our Yiddish word for today, and that we're going to do this zusammen, and that means together, because we're going to do this remote learning zusammen together. Move on to 8.2.3. I want to go over factoring and zero product property. Here's a typical quadratic, and we want to factor it. In other words, we have the sum on this side, and we want to develop the product. We're factoring to find that product. This is the first step, actually, for doing zero product property, is doing the factoring that we did just before school was taken out. So once again, we're going to go ahead and we're going to use our box and diamond, a generic rectangle and diamond, in order to factor our quadratic. So we'll go ahead and place x squared here. And you should remember that what goes into this one, negative 15. And then we multiply them together to get the top of the diamond, negative 15x squared. Then we take our b term, negative 2x, and we place it on the bottom. Now we have to figure out two numbers, solve this little puzzle, that add to negative 2, but multiply to negative 15. Well, obviously that would be negative 5x and 3x. Because negative 5 times 3 is negative 15. Negative 5 plus 3 gives us negative 2. And then we could place these into our generic rectangle. Now we solve this. We solve a generic rectangle. We get the base and the height of it. So these are obviously x. And x times negative 5 is going to give us negative 5x. And x times 3 gives us 3x. And we make sure that this corner works. 3 times negative 5, negative 15. So our product here is x minus 5 and x plus 3. Now we're going to do zero product property. And in zero product property, we have to take our quadratic and we're going to set it to 0. And we know that this quadratic can be rewritten as a product. The reason for doing this and setting it to 0 is that when it's equal to 0, that's when it crosses the x-axis. So we're going to go ahead and we're going to break this out, and we're going to get these both equal to 0. Because they're being multiplied together, either this factor is 0, or this factor is 0, or both of them could possibly be 0. So we're going to go ahead and say x minus 5 equals 0 on this side. X plus 3 equals 0 on this side. Well, obviously, if we add this 5 over here, we get x equals 5. If we subtract 3 over here, we get x equals negative 3. And these are what we refer to as the roots. Also referred to as the zeros of our quadratic. Here is, I'm going to quickly make a graph with at least going to 5 on the x-axis. And I'm going to go to past negative 16 on the y-axis for various reasons, which I'll explain in a moment. But first, what does it mean that we have these 5 and this negative 3 here? Well, what it is that these are a parabola. Remember, a quadratic, okay, maps a parabola onto a 4-quadrant graph. So if we take this, and we were actually able to plug in all the numbers like 1, x is equal to 1, x is equal to 2, x is equal to negative 3, and so on and so forth, it would be able to graph a parabola out of it. But now, since we go ahead and use zero product property, we have the x-intercepts for that parabola. It's where it crosses the x-axis. So we know it intercepts here, and we know it intercepts here. 5, 0, negative 3, 0. That's why they call them the zeros. And we also know, since our third term, the c, is negative 15, that's our y-intercept. Because you plug in 0 here, this is negative 15. So we have negative 15 also down here. Last thing that we're going to need is to find the vertex. And to find the vertex, you got to find, if you remember, between those 2 points is our line of symmetry. So the distance between negative 3 and 5 is 8. And half of 8 is 4. So we can go ahead and count in 1, 2, 3, 4, which is right here. 1, 2, 3, 4. It's right here. So this, at x equals 1, is our line of symmetry. And we know with a line of symmetry, that's where the vertex is going to be, somewhere on this line. So then how do we find the actual vertex where it's going to intersect? We find it by plugging in 1, this x equals 1, into the actual quadratic. We can say, okay, well, when x equals 1 at x squared minus 2x minus 15, we know when x equals 1, and we're saying here x is equal to 1 because of this line of symmetry. We plug it in, we go 1 squared minus 2 times 1 minus 15. Well, 1 squared is 1. 2 times 1 is 2, so 1 minus 2 minus 15. 1 minus 2 is negative 1, minus 15 is negative 16. That means our y is equal to negative 16. That means that our line of symmetry, our vertex, is at 1, negative 16. And with that, we can draw our parabola. What we want to make sure we do is that we label all the important points on here. So our line of symmetry at x equals 1, we're going to put that there. We're going to say this is 5, 0. We're going to say this is negative 3, 0. Of course, I have my axes written in, x and y. I'm also going to make sure that down here, that my y-intercept at 0, negative 15, and 1, negative 16 for the vertex. You don't have to write what they actually are, just as long as you put those items in. Of course, also make sure that we put the actual quadratic on the curve on the parabola. So x squared minus 2x minus 15 is the quadratic for this parabola. So to end this video, what I want you to do is actually go ahead and get the zeros and graph for this quadratic that I have in front of me right here. 2x squared plus 5x minus 12. Try it on your own. Get the zeros,